structs and interfaces is pretty simple. To tie them together rather than have classes, what they've done is they say you have a function, and before we saw the main function, right, there was this section right here was missing. So if you want it to be available on a struct, you put in either the data type or in this case a pointer to a connection. And now if we have a BGP connection, we can do connection.announce, right, and call this method on that. And then instead of it being implicitly be called this, we can name it whatever we want. I've called it con in this case. I could have called it this. It's not a keyword. So that's all there is to it, right? You just say this is the receiver, right? So we've got a function, and here's the receiver. So one of the bizarre things, and they were trying to avoid the null pointer exceptions, sort of. So it's not bizarre, it's actually quite good. I shouldn't say bizarre, it's not the right word. Right here, when you say declare a variable con and say that it's a BGP connection, that's that fully initialized struct with the default values. That's not nil or null. That is an initialized BGP connection. So, just like in Java, an int will have a default value of 0 if you don't initialize it. Well, everything has a default value here. The memory's been allocated. So we'll notice some other things on the next line, right? We have a net. We can call parse citer, pass it a string. And we can see here that we have multiple return values, right? Underscore, like in most functional languages, means I don't give a hoot what it is. I'm going to ignore it. And then it returns a prefix and an error. And it's very idiomatic to return an error in the last position, and then to say, if the error is not nil, do something. That is idiomatic Go. And unlike Scala, where